This is section 8.5. We're going to be talking about exponential growth and decay. The homework is 80 through 96. First thing we're going to do is graph the exponential function. So let's suppose I have f of x is equal to raised to the x. So what I'm going to do is I'm going to take my x value and plug it in for x. So I have 2 raised to the negative 3 power. Well, if you recall negative exponents, that means you have to move either from the top to the bottom or bottom to the top. So instead of 2 to the negative 3, I'm going to write 1 over 2 to the positive 3 exponent. So I start with a negative exponent on top, and then I'm going to move it down to the bottom, and it now becomes a positive exponent. So I have y equals 2 raised to the negative 3, which becomes 1 over 2 to the third power. Remember, 2 to the third power is not 2 times 3. It is not 6. It means 2 times 2 times 2. So I have 1 over 2 times 2 times 2, which gives you 1 over 8. In the same way, we're going to plug in all of these x values. I have 2 to the negative 2, which is 1 over 2 squared, which is 1/4. 2 to the negative 1, 1 over 2 to the first, which is 1/2. 2 to the 0. 2 to the 0. Remember, anything to the 0 power is equal to 1. Be careful with that. It is not equal to 0. It is equal to 1. I have 2 to the first power, which is 2. 2 to the second power is 2 times 2, which is 4. And 2 to the third power is 8. What I'm going to do is I'm going to graph or plot each of these points. So let me clean this up a little bit. I'm going to plot the point negative 3, 1/8. Well, 1/8 is kind of hard to graph because it's so small. So I'm going to my x value, 1, 2, 3, negative 3. And my y value is just really small. So what I'm going to do is I'm going to put a dot kind of as close to that x-axis as possible. My next point is negative 2, 1/4. Again, I'm not moving up very much, but it is a little bit higher than 1/8. Negative 1, 1/2 is going to be halfway between 0 and 1. Okay, so it's up a little bit higher. 0, 1. My x value is 0. My y value is 1. 1, 2. Go to the right 1 and up 2. 2, 4. My x is 2 and my y is 4. And then 3, 8 is going to be up here. Okay. Notice if I get bigger x values, this point over here is going to get very, very tall, and I'm not actually tall enough to reach that far. And if my x value gets smaller, I'm going to get closer and closer to this x-axis. Now the thing with exponential functions is you never actually cross this x-axis. You get close to it, you get really, 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 really close to it. And I'm going to change colors here. You get really close to it, but you never actually cross it. So when you draw exponential graphs, you don't actually cross this x-axis line. Okay, you get close to it, but you don't cross it. The other thing that you need to notice is that every exponential function goes through the point 0, 1. And in fact, it doesn't matter what that number is. A couple exceptions. If it's a fraction, then that's something else. But if it's 3 to the x, it still goes through the point 0, 1. If it's 10 to the x, doesn't matter, still goes through the point 0, 1. Another thing that exponential functions, the graph of exponential functions have, are what we call horizontal asymptotes. An asymptote is when you get closer and closer and closer and closer and closer to a line, but you don't actually cross it. Well, I said that we get closer and closer and closer to the x-axis. Well, the x-axis, if we were to graph that, that actually has an equation to it. That is y equals 0. And if you notice, if you look at this y value right there, you notice your y value is indeed 0 on this line. So what we have for exponential functions, for every exponential function, you're going to have this point right here where it goes through the point 0, 1. And then you're also going to have what we call a horizontal asymptote. It is going to be an equation of a line, y equals some number. And if it's just a plain exponential function, then it's going to go through y equals 0. In general, we have an equation of exponential function. B is the base raised to the x minus h plus k. K is outside of the exponent. When it's outside, that always shifts the graph up and down. We have talked about this before. We will talk about this again. When you have h and k, where k is outside, whether it's outside of the square root, whether it's outside of the parentheses, whatever, whenever it's outside, it goes up or down. And h, which is inside, in this particular case, it's inside the exponent, it's going to go left and right. Left and right. Be careful with the left and right. If it's negative, it goes in the positive direction. If it's positive, it goes in the negative direction. The left and right always goes opposite of what you would expect. So, once again, it does not go through 0, 0. It goes through the point 0, 1. Every exponential point or exponential graph goes through 0, 1 unless we shift it. And the horizontal asymptote is always going to be 1 unit below this point right here. So let's graph f of x is equal to 2 to the x plus 1. So notice we've got this plus 1. It is outside of the exponent. Outside means up or down. Since this is positive, that means shift it up. So normally our graph goes through that point right there, 0, 1. But since we've shifted it up 1 unit, instead of going through that point, we're going to shift it up 1 unit. It's now going to go through the point 0, 2. Traditionally, the horizontal asymptote is at y equals 0. But that also gets shifted up 1 unit. So what I'm going to do, I'm going to draw in. I'm going to use a dotted line because it's not actual part of the graph. It's kind of an imaginary line, but it does help us graph. So our horizontal asymptote is 1 above what it used to be, or in this case, y equals 1. And to actually draw the graph, all I'm looking for is a sketch. I don't need points other than this one right here. And remember, you get close, 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 and it goes up really fast. But it does not cross this dotted line. It's a horizontal asymptote, y equals 1. Again, I have f of x is equal to 3 to the x minus 2. It doesn't matter what this number is. It's always, the exponential graph always looks the same. Traditionally, it goes through this point right here. But notice I have this negative 2, which is outside of the exponent. So that's going to shift my graph down 2. So down 1, down 2. So now my point is here. So it's gone down 2 units. And my horizontal asymptote, which is normally at 0. And no, you don't have to draw in this squiggly line. I'm just showing you where it is. That also gets shifted down 2 units. So if it starts here and I go down 2 units, here's 1 unit, 2 units. So my horizontal asymptote is down here, which is y equals -2. So this horizontal asymptote, that's the line that we do not cross. So we have to go through this point right there. It always goes up and to the right. Again, it doesn't matter what this number is. We have 5 raised to the x plus 3. Notice the plus 3 is actually inside the exponent. That's going to shift us left or right. And if it's positive, it's going to shift us left in the negative direction. So we normally start here, but if I go left, 1, 2, 3, and there is that point right there. Okay, so we don't need that one anymore. The horizontal asymptote, we're not moving up or down, so traditionally it's at 0, it's going to stay at 0 at y equals 0. And get close to the asymptote, but don't cross it, and go up and to the right. This one I shift in 2 different directions. I'm going to go up 3, and I'm going to go to the right 2. So normally it starts here. I'm going to go up 3, 1, 2, 3. Now I'm not going to the number 3, which would be here. I'm going up 3 from where it started. So I start here, go up 1, 2, 3, and to the right 2. So this is the point I need. Erase this one because it does not go through that point anymore. And so here's where the asymptote normally is, but I don't need it there. It has been moved up 3 units as well. So this one's going up 3, so 1, 2, 3, my horizontal asymptote. Yes, you do need to draw that dotted line. Is going to be at y equals 3. And the graph, get close to the asymptote, but don't cross it, and go up and to the right. This one's slightly different because I have a negative. Just like when we're graphing anything, if you have a negative in front, that's going to flip it upside down. So instead of going through this point, I'm going to take the graph and flip it upside down. So it now goes through this point. Okay. And instead of going up this way, we got to turn that upside down. So it's going to go we still have to get close to the horizontal asymptote. We didn't shift it, so the horizontal asymptote is still going to be at 0, but it's, instead of going up, it's going to be going down. Notice this also has a negative. It doesn't flip it upside down. This negative actually is going to flip it left to right. So I'm still going through this point right here, but instead of going up and to the right, I am going to go down on the right-hand side. So here is my graph when the x value is negative, and my asymptote is still at y equals 0. I am going to pause here. This will be the end of part 1.